Welcome to another session of analytical geometry revision video. Carefully watch and enjoy this video. We come to another question of circle and tangents. We have A, D, U, Q, M, E, many points on the diagram. And the equation of the circle is available: x square plus y square plus 8x minus 6y equal to minus 5. Now let us look at the question. Determine the coordinates of M, the center of the circle. A question of 4 marks. So we have the equation of the circle and we must find out or calculate the center M of the circle. Here we are going to use the method of completing the square. X square plus y square plus 8x minus 6y equal to minus 5. Now we rearrange the equation as x square plus 8x plus y square minus 6y equal to minus 5. Now listen to the method of completing the square. We need to complete the squares. Now when we look at the equation, x square plus 8x is not a perfect square, but if you add the square of 4, that is 4 square. How do we get 4 square? Half of 8 is 4. We take the square of that number 4. So we have an additional number now, 4 square. But we make sure that we add the same number on the other side of the equation so that the equation is valid. Same thing with the y terms. We take the coefficient of y, that is minus 6. Half of minus 6 is minus 3. We add the square of minus 3 on both sides. Now look at that. X square plus 8x plus 4 square is the expanded form of x plus 4 whole square. So we get x plus 4 whole square and y minus 3 whole square equal to, the right hand side we use the calculator and simplify, we get 20 on the right hand side. Therefore, from the formula for the equation of the circle, we still remember it is x minus a whole square plus y minus b whole square equal to r square. From there, here it is x plus 4 whole square. So the x coordinate of the center is minus 4 and the y coordinate of the center is positive 3. Now m is minus 4, 3. The question continues. Calculate the coordinates of Q. Where is Q? Q is on the circle as well as it is on the y-axis. And we have the equation of the circle from the previous question. X plus 4 whole square plus y minus 3 whole square equal to 20. Now, the x coordinate of Q becomes 0 since it is lying on the y-axis. So, we assume Q is 0, y. Since it is lying on the circle, we can substitute the coordinates of Q. The x coordinate is 0, so we put 0 plus 4 whole square plus y minus 3 whole square equal to 20. So the unknown value of y will be calculated. We simplify the equation. 4 square is 16. 20 minus 16 is 4. So we get y minus 3 whole square equal to 4. Taking the square root on both sides, we have y minus 3 is equal to plus or minus 2. Then y equal to 3 minus 2 equal to 1, or it can be 3 plus 2 equal to 5. But from the diagram we can see that the coordinates of Q must be Q 0, 1. Again, question C from the same diagram. What is it? Calculate the equation of tangent UE. UE is a tangent which is touching the circle at the point Q. Tangent is a straight line. We must calculate the gradient of this straight line, and then we can write the equation. We need the gradient and at least 1 point. Now look at the points we are going to use. We are going to calculate the gradient of the radius first. We have the coordinates of m minus 4, 3 and q 0, 1. Using these 2 points, we get the gradient of the radius is 3 minus 1 over minus 4 minus 0, which is 2 over minus 4, and that is minus half. And we learned in the previous lessons that is tangent is always perpendicular to radius, or radius is always perpendicular to tangent. Then using the property of the perpendicular lines, the gradient of the tangent can be obtained by dividing minus 1 by minus half, which gives us positive 2. Now we apply the formula. The formula for the equation of a straight line is y minus y1 equal to m times x minus x1. The formula is available on the information sheet. We substitute the point Q, y minus 1 equal to 2 times x minus 0, which is simplified to y equal to 2x plus 1, the equation of the tangent. Here is another question. Write down the equation of du. Now what is du? Du is a straight line parallel to the x-axis given in the question, and then we understand that the y-coordinate of any point on the line du will be 6, because 6 is the y-coordinate of D. Therefore, the equation of du must be y equal to 6. Next question, calculate the coordinates of u. Coordinates of u. U is a point of intersection of DU and UE. And we know the basic idea of calculating the point of intersection. Solve the two equations. Equation of UE is y equal to 2x plus 1, and equation of du is y equal to 6 from the previous questions. Now our job is to solve these two equations simultaneously. So we write 6 is equal to 2x plus 1, and then we solve for x. X is equal to 5 over 2. So the x coordinate is 5 over 2 and the y coordinate is 6. So u is 5 over 2, 6. Prove that QUAD is a cyclic quadrilateral. QUAD. Now we do have all the coordinates. U is 5 over 2, 6. U is 0, 1. Okay. Let us start now. We learned cyclic quadrilateral in Euclidean geometry. Now in this question, the gradient of AU is 11 minus 6 divided by 0 minus 5 over 2, which comes to minus 2. And gradient of AD, using A and D, we get 6 minus 11 divided by minus 10 minus 0 gives us half. We multiply these two gradients. Minus 2 times half gives us minus 1. What do we understand from that? Then we understand AU is perpendicular to DA, or angle A is equal to 90 degrees. Again, angle DQU, look at that. Angle DQU. Tangent is perpendicular to radius. So angle DQU must be 90 degrees. So in the quadrilateral QUAD, we have angle A is 90, again angle Q is 90, making 90 plus 90, 180. Therefore, QUAD is a cyclic quadrilateral.